Hello everyone, I'm Andrii and I'm here to present the rabbit hole of dependency in Golang. And let's slowly get started. First of all, again, I'm Andrii, I'm a principal software engineer at Delivery Hero. We are using Golang a lot in all of our services, and I have a lot of examples, good and bad, how to work with dependencies. And that's why today I wanted to show you some problems we've had in our code base. So if you want to contact me and discuss some of the topics, you can easily contact me by any of these, LinkedIn or Twitter or Medium, whatever. Please feel free to reach me out there. Yeah, let's slowly get started. And the first of all, I want to ask you, can you clearly name a couple of dependencies in your current Golang project and why do you need them? Just take a time, think a bit about this. And the next question I would like to ask you, can you clearly name a couple of indirect dependencies in your Golang project and why do you need them? And again, maybe press some pause on the video and think about. But during the presentation, I would ask you know to think about this. And yeah, but we are going further. First of all, I prepared very simple Golang program for you. And yeah, you see it doesn't have any dependency, doesn't have any include in the program. It uses very default println and it prints hello world. So if we just take this and compile, our compiled file will be almost 1.5 megabytes. This sounds decent. Is it big or not? We will figure in my presentation. Let's just to use some imports. Let's import another very standard library from the Golang. It's FMT. Everyone is using it. I can't imagine any Golang projects where this is not being used. So we're using FMT to do the same, just to print hello world. And let's check how the size of our application is going to change. Surprising, it's actually changed. And it is 1 more megabyte in the project. So if we compare the size of our application, it's actually changed almost in half. It's plus 50% off compared to the previous result. And why this happens, I will explain a bit more. And let's look if we add more dependencies into your code. So we added in auth. Why we adding? Because we want to read some arguments we providing when we run the program and maybe output them. For example, just put my name, hello. And if you're going to compile this, the size of the compiled program almost doesn't change. And this is something which already should ring the bell. What is going on actually? I just added maybe huge another dependency to the code, but actually it's not reflected in the, and here you can see, if you compare, it was 51%, right now it's 53, but yeah, not the big change. But the answer to this, well, this is not a problem, but answer to this puzzle lies in the FMT library. If you check FMT library, you will find out that in print Go and some other of them, you're actually already including IO and libraries. So this is a hidden dependency coming with FMT when you include it. All of this is actually used. For example, reflect IO we are using, I don't know, for outputting your prints to some writers. It's very common in Golang. Reflect you might use if you, for example, when you formatted, you want to output the type of your variable you're providing, or if you want to print some information about the content of the object. Here, conv you're using to convert integers, or not only integers, but numbers into strings. Sync is puzzling me why we need sync, but most probably it has some usages in the packages. And yeah, for sure you have Unicode because you may play around with Unicode. So when you include FMT, you also include a bunch of other dependencies among this. Yeah, this is something you need to understand when you are working with your program. So yeah, this is what I already mentioned. Adding FMT, you bring a lot of hidden dependencies. And these hidden dependencies, they may have another hidden dependencies. And we can go into this rabbit hole very deep, maybe. I don't recommend, but yeah, we can do this, actually. So if we try to do something more sophisticated, or what I wanted to experiment, thought, okay, if I move my code to some external library, how this is going to affect the size of my package at the end. So I created external library. This is the code of this library. And yeah, I format it as a library. I upload to the GitHub, and I imported it in my program. So it's a simple function, message print. And when I compile it and when I check the size almost didn't change. So moving your dependency to external library doesn't bring something new, actually, because you already have all of this in your program. So yeah, if you compare, size almost didn't change, absolutely the same. So then we need to ask ourselves a couple of questions. If we try to do something more interesting, and like we were playing around with very simple code before, we were just printing some out. What if I need to print out the list of S3 buckets I have in my account? And the code for this program will be also very simple compared to the previous one. So we have some external dependencies. We are introducing some generic library for AWS. We have sessions because we need to authenticate. We have S3 itself. And then we're creating session, we're creating a new service, and we call please list the buckets and then go in the loop to print all of these buckets. Very simple code. What can go wrong? Nothing can go wrong, but what will be the result? Let's check what is the result. So when we compile our application, actually the size of the application jumps a lot. And this is interesting thing, I would say, because if you compare like our size of application actually increased by almost 900%. So these offers here exactly for comparison to show how the size of the application increasing. So you really can see it jumped to a bigger number. So why this happened? If we ask ourselves, yeah, maybe this is a huge package. It has a lot of APIs. It has a lot of different objects. So maybe all of this together creates a huge dependency or hidden dependency we're injecting. And what I thought, okay, AWS stays for web services. This is Amazon Web Services. So it means it has some API, and we can call this API directly and just get the same result. For sure, it has some complications about authentication. We need to sign our request, but we can figure out this. So what I did, I just asked ChatGPT to generate a code. This code actually works, and the code itself that is not interesting for us at all. It works, you can believe. What is more interested for us is this list of dependencies we have. So we have a working code which can call list of buckets, but all of these AWS dependencies. This is clearly only from the default Golang packages. So when we compile it, our size has decreased. It's 6 megabytes less right now, but still it's 8 megabytes. And the program I was showing before, it's actually like 100 lines of code. It's not something huge. Amount of dependencies we importing is also not that huge. Why do we have this problem with still, I would say, inflated size of the application? And yeah, you can see it's decreased a lot. It decreased almost 400% compared to the previous one, but still it's big. What can we do to solve this problem with our application? or why this happened. And again, we implemented only one API call in our program. And this S3 has multiple calls to list object, to add object, remove object, update, to get versions. It's a huge amount of API calls. So maybe the 6 megabytes we just removed from our application, the 6 megabytes is exactly implementation of this code. But still, our application is still big. It's still big. If we compare to the previous one, it was 2 megabytes. Right now it's 8. So this 6 more megabytes of the program. So which of this dependency take all the credits for abusing the size of our application? So I did another experiment. I started to remove one by one. This crypto sounds a good candidate to remove. So what I did, I commented code to still keep the program working and try to compile. I did it. So yeah, I removed crypto. There is no crypto dependencies anymore. And I compiled it. I compiled it, but size of the application didn't change much. You can see we gain only 4 kilobytes. Okay, my thought was, let's proceed removing more and let's find out which one actually is the reason for this inflated size of the application. So we also removed, there is no encoding in our application, and we run, and this is not the mistake, actually. This is two different screenshots, but unfortunately, there is no effect. Nothing has changed in our program. So most probably this encoding comes with another dependencies as a hidden one. So we need to build the tree of dependencies to understand what could be abuser of our size. Still we have 8 megabytes. Nothing has changed much. So I decided to proceed to removing stuff. So I removed time library and nothing has changed almost. I removed IO and the same, IO already included in FMT, so will not bring anything. But we have only FMT auth, which is also included in the FMT as a hidden dependency. And we have net HTTP. And what I did next, I created a simple program using only net HTTP, just to call random URL. And if we compile it, actually our application becomes like 5 megabytes. So and net HTTP is another very common library we have in Golang. Maybe 99% of applications using it because we need to communicate our application with other applications, so we're using it. So it brings another batch of dependencies. And and why I'm bringing this? I'm for sure not encourage you to remove all your dependencies from the code base, and I'm not encourage you to remove or implement net HTTP on your own to have zero dependency and very light code. But what I'm trying to say was probably you would never bother yourself to look into size of your application when you remove something or add something, and you didn't know that how many dependencies it brings when you add a small library to your application. And and maybe NetHTTP is not the biggest one, but this is common one. And when you add it, you really don't understand what it brings to your application among with this, what the dependencies of dependencies go to your application. And what I want to bring into the table is that when you work with in a big company, for example, like Delivery Hero or even smaller, you need some culture of dependency management. If you don't have it, you can face some issues. And the second part of my talk will be again exactly about these issues. We face it in our code bases a couple of times. And like I mentioned in this slide, it needs you risk to have very poor code quality. It doesn't really go to this bad things, poor code quality, but it leads to a lot of technical debt, which you cannot remove forever. Okay, and proceed with my presentation. I want to give you some small example. So just imagine you have a service, some global service. I call it the STS because this is common name around the world, and it stays for service to service tokens. And this service commonly used in different ecosystems to create a token to communicate between services. So let's imagine we have this global service. And since this is a global service and everyone needs to adopt it, we also want to support our teams to not implement a well every time, but reuse something. So we create some library. So in different languages, Java, Kotlin, Python, Ruby, Golang, we implementing some helpful libraries which abstract communication or abstract some this API layer for your application. So some teams just need to plug and play and use this library. Sounds easy and sounds like a common sense, and this is what we are using on daily basis all the time. So we have this in service, we have this library, and we have service A. This is just some business service which executes some business and it needs to use this service to service token. So we use this library, and what I forgot to mention, the library has version and version 1. This is important for future. And we're using everything works, and then team decides to implement version 2. And what they actually do, unfortunately, and this happened in my career a couple of times and in Delivery Hero as well, guys implementing new features and changing the contract. They changing interfaces, and this leads to inconsistency and no backward compatibility between version 1 and version 2. And what happens next? Even if team of service A, if they want to migrate to a new version, they would need to do some extra effort to do this migration because interfaces change it. They need to rewrite some code, and maybe not in one place, but in multiple places. This leads to the case when team decides to stay with version 1 because it works for them. And in software engineering, we have this proverb, if it works, don't touch it. So the team is not going to touch it, it will stay, they will not going to use version 2. And here another problem, because like teams who creating these global services, who maintaining the libraries for these global services, they also don't have a lot of capacity. So they can maintain both versions simultaneously. And usually they say, okay, this is deprecated, we're not supporting it, we will not implement new features, we will not implement security updates. All of you should use this new amazing shiny version 2. Okay, so team of service A stays with this technical debt almost forever, I would say. And then happens what happened in my experience multiple times. We have another global service. And it's a global service doing some stuff, and also another team decided, okay, to help team, we need to implement this library to support easy plug and play for our consumers. Okay, they did, but they also use this service to service token. And for sure, since they creating a new service, they're not going to use old version. They're going directly with version 2, which has different interfaces compared to the version 1. And this starts to create a problem. If service A wants to use this service and they use this library, it may have some dependency on what is implemented in STS. And in this case, when you try to install the library from another global service, it won't work. What it will tell you that, oh, I see a different implementation of some functionality which has the same name and it stays for the same library actually. It will fail. And this is something what happened in my company a couple of times. And this is something really huge problem for us. And if you look what the problems, it's hard to maintain multiple versions. As I mentioned, the team which created this library, they may not have capacity to maintain version 1 and version 2 and keep different interfaces. These are hard to push other teams to migrate to a new version. As I said, they also don't have capacity. And for them to assure their product people that technical debt is something bad and we need to migrate, it's usually very complicated. At some point, the loop will be closed and you will end up with some services are not able to use your libraries, as I mentioned in the example above. It actually takes a lot of time to end up to this situation. This is a problem because what I described didn't happen in day or week. It happened during like year or couple of years. And then this situation evolved. You may develop more code in service A with this old dependency to old library. And at some point, it's super complicated to avoid this technical debt or get out of it. You have years of development on top of this, and it's more and more complicated to change or rewrite your code. And it really requires huge investments to fix the problem. And sometimes people even say, okay, it's really easy to start a greenfield project rather than trying to solve it in place. And yeah, what is the biggest problem was in this case, I need to mention, because also the team who is maintaining the library, they did a mistake. We need to acknowledge this and understand when they were creating a new version, what they did, they just said, okay, we have a version 2, and they changed it to another version. So in the same version, it shouldn't be changes in the contract, actually. But unfortunately, guys did this, and it created all of these following problems. And what they had to do, and usually was probably working with Go programs, you notice this multiple times, they had to create a kind of separate folder in their project and call it, we should have a separate Go mode actually. Then it will be used as a separate package, and it will solve the problem I described previously. Because if you look at your GoSum, and this is GoSum from the real project, for example, Google.com has this amount of different hidden or indirect dependencies. Why? Because we have dependency, then we have another dependency, then we have another hidden dependency, and it could be different, or like huge amount of layers of dependencies. And each of them may have their own Go model with specified versions. And this can end up. So in this case, guys was keeping the contract the same, maybe adding new features, some fixes, but the contract was the same. And this didn't break anything. In our case, the break happened somewhere here, and then we can proceed without code modifications, big code modifications, I would say. So unfortunately, this is a very common example, and in my years in the company, I have seen this multiple times so far, in different projects, and this happens over and over. If you go to the next example I have, this I called helper packages. This is also very common. At some point, like when our project evolved, we write in code and we find out we have some common parts we can reuse and move to the some common library. First of all, inside the project for sure. And we create these helper packages or called tools or whatever. It may have different names, but idea the same. We applying the dry principle and we removing duplications of the code. And in this example, I have package buffer and I have some helper. Helper has some random function just for this example. And what we decided, okay, we are going to create another function inside our helper package. And this function is going to print some information about our gopher. So it was going to just print some formatted strings, the name with the age and position. And then, we can call it in our main project. Oops. We can call it in our main project. And we call it, and this is how it works. Unfortunately, I placed the slides in the wrong position. Yeah. What is wrong in this example? So we have helpers and we have dependency to the Gopher object or another library in our project. And at some point, it can lead to the situation when we would need some helpers from the Gopher package. And then what happens, we will create a link to the helper functions here. And it will create circular dependency, infinity loop, I would say. To avoid this, what we would need to create another helpers, let's call it Gopher helpers. And this, again, duplication of the code. So we are not solving situation, we are making it worse. So yeah, this is what I already mentioned. Because when you create the helper, and when you use the helper from one library, you automatically adding this dependency to the Gopher package to all packages where you use it helper. And this creates some dependency tree, which at the end could lead you to the circular dependency. Yeah. In my example, it's like very short path to do this, but usually, again, it takes months, years, until you at some point need to reuse something from the helper when you're inside the Gopher package, and you can't because it doesn't work. So how to solve it? This is an easy example, and I see such examples everywhere in the code. This info function should be part of our object. It should be a method inside our object. So we can easily access information from the object. We even don't need to make this information public. So it could be with lowercase name, lowercase h, and then we can print this information. And this is how it's used. This is better, I would say. You can argue with me, but this is better. And as I already mentioned, this is another problem I see in our code base a lot. So people missing conceptions, people not really thinking in advance and not applying common sense when they're moving some parts to the helpers. And sometimes they don't see this pattern that this should be a method of the object. This shouldn't be a separate helper function. There is no any reason to have it as a separate function and create all of these dependencies. So going back, I have, not going back, going further, I have another very common example related to the helpers, because when you try to apply this drive principle, you are trying to apply it almost everywhere. So you start to know, first of all, you try to remove duplications inside your services. Then you see that another service also has dependency and you're moving already some duplications from different services and so on and so forth. So this is example. We have a service A, and at some point we decided we need to create a helper package because we have some dependency duplications in our code base. We created helpers that work for us perfectly. But then we have very similar service B, very similar helpers library inside. And then we think, okay, there is no reason to do modifications in two places. Let's move out this package to some external one, and then we're going to reuse. But here, again, we have the same problem with capacity. Maybe one team has enough time to work on the technical debt, removing these helpers from here or here. Maybe another team doesn't have the capacity to do this. And we end up in a situation like this. One service using these helpers, another service doesn't use these helpers, or maybe even worse, and this I dislike more, that this service still has a library with helpers and some part of the code still use it. But also we already trying, to migrate to the new solution, and some of our parts of our code using the new implementation from the external library. This is a huge problem, and because implementations here may go into different directions. You may have similar name of the function with different implementations and different behavior, and also with different vulnerabilities. But unfortunately, this is not the worst case I have seen in codebase, actually. The worst one is this one. In this situation, we have another service also implementing this library. And for some reason, for example, we have another library we're using from this service, or I don't know, some batch of services. And then it opens us the door to use helpers from this service as well, if we embedded it as a, not embedded, if we use it as a dependency in service A. And then we have free dependency with absolutely similar code. So our Andrii principle just failed, drastically failed. And I want to emphasize this is the real case. This is the real case I have seen in Codebase a couple of times, which made me very sad. Yeah. Yeah. About conclusions, your team acquires strong dependency management culture. Not only your team, it should be enforced on the company level. It should be enforced on the team level. You need to work with your product people to prioritize technical depth and remove unnecessary dependencies. As you remember, I asked you at the beginning, can you name a couple of dependencies you have in your current project? And then can you name a couple of indirect dependencies you have in your project? Hope you can name some of them, actually. But let's go. You need to document dependency policies. So it should be written, it should be followed by the people. You should use this guidance to minimize and define what dependencies are, how they should be used. You should do regular dependency audit. You need to update versions. You need to detect and fix vulnerabilities. This is actually super serious stuff because you may use some library in your code base which is indirectly using another library having vulnerability, and you already exposed it to the problem because your application could be attacked and you even don't know why, actually. So please update your versions, check your vulnerabilities. There are some tools to do this. So please follow the best practice and follow the common sense. Don't skip imports section during PR review. This is a problem I noticed multiple times with the guys. So I mentioned this. Let me go quickly back. Yeah, this slide. This happened because actually guys were ignoring these first sections of imports in the program. They were skipping, right? What could go wrong in the imports? But imports was saying, okay, the new library is going to be added to your project. And this library is very different from what you should use, actually. If this won't be ignored, it will be solved way before when we faced some circle dependencies in our code base, or when different parts of the code using look similar implementation, but actually implementations are super different in them. And yeah, that's all from my side. I have a couple of slides. So yeah, we are hiring. And if you want to help me to build this good dependency management culture in Delivery Hero, please join us. We have a couple of positions in the company. And yeah, if you have any questions or you want to discuss this topic or any other topic, please don't hesitate to contact me using any of these websites. And thank you guys. Have a nice day. Bye-bye.